Good afternoon, dear students of class 9. I think all of you are well. Now I start the chapter motion, which is the continuation of last video. Acceleration. Acceleration. What is acceleration? Already I discussed in your last video. What is acceleration? The change in velocity, per unit time is called acceleration. Is called acceleration. Acceleration in mathematical forms, acceleration equal to velocity, change in velocity by time taken. Dimensional formula of acceleration. Dimensional formula of acceleration equal to L e to the power minus 2. Okay. There are 4 different types of acceleration. There are 4 different types of acceleration. There are 4 different types of acceleration. Number 1, uniform acceleration. What is uniform acceleration? When a body travels in a straight line and it increases its velocity by equal amount in equal interval of time, then the body is said to have uniform acceleration. So when a body travels in a straight line, and it increases the velocity by equal amount in equal interval of time, then the body is said to be said to have then the acceleration is said to have uniform acceleration. Explanation. When the velocity of a car increases, then it is said to be accelerated. When the velocity of a car increases, then it is said to be accelerated. If the velocity increases at a uniform rate, then the acceleration is said to be uniform. If the velocity increases, at uniform rate, then the acceleration is said to be uniform. Then the acceleration is said to be uniform. Now examples. Examples. The motion of a body rolling down a smooth inclined plane. The motion of a ball rolling down a smooth inclined plane. Number 2, the motion of a bicycle going down to slope of a path, when the rider is not pedaling it. This is the examples of uniform acceleration. Okay. Now non-uniform acceleration. Non-uniform acceleration. If the change in velocity, non-uniform acceleration. If the change in velocity is not equal in equal interval of time, if the change in velocity is not equal in equal interval of time, then the acceleration is said to be variable or non-uniform acceleration. Non-uniform acceleration. This is the abbreviated form of acceleration. Now, I give you some example of non-uniform acceleration. Examples. The motion of a car on a crowded road. The motion of a car on a crowded road. Second, the motion of a train entering the platform. The motion of a train entering the platform. Okay, these are the examples of non-uniform acceleration. This is the second. Now positive and negative acceleration. Now, positive and negative acceleration. Negative acceleration. In our last video, I discussed that acceleration equal to acceleration A equal to V minus U by T, where U equal to initial velocity, V equal to final velocity, and T equal to time taken. Now I discuss third number of. Now number 3, that is positive acceleration. From the above equation, A equal to V minus U by T. If V greater than U, then A is positive. Then A is positive. If the final velocity, if the final velocity is greater than initial velocity, is greater than initial velocity, that is the velocity increases with time. That is, the velocity increases with time. Increases with time. This is called positive acceleration. This is called positive acceleration. Positive acceleration. Now, number 4. Negative acceleration. If V is less than U, then acceleration A is negative. If the final velocity is less than initial velocity, is less than initial velocity, that is less than the initial velocity, that is the velocity decreases with time. Decreases with time. This is called negative acceleration. Negative acceleration. Negative acceleration is also called retardation or deacceleration. the topics in end. Now I start. Now I start. Equations of motion. Equations of uniformly accelerated motions. Uniformly accelerated motion. These equations are very important because with the help of these equations we can calculate initial velocity, final velocity v, uniform acceleration a, and time t. The first equation of motion v equal to u plus at. You know from the previous lesson, v equal to final velocity, u equal to initial velocity, a equal to uniform acceleration. Now we prove these equations. Consider a body having initial velocity having initial velocity u. Suppose it is subjected to a uniform acceleration a. Suppose it is subjected to a uniform acceleration a. For time t, the final velocity becomes v. From the definition of acceleration, we know that acceleration a equal to acceleration equal to change in velocity by time taken equal to final velocity minus initial velocity by time taken. So A equal to V minus U by T. That means we can write AT equal to V minus U, or V equal to U plus AT. Proved. This is the first equation of motion. Now, the second equation of motion. Now I discuss the second equation of motion. The second equation of motion. S equal to ut plus half at square. Suppose a body has an initial velocity u and uniform acceleration a, and uniform acceleration equal to a. For time t, the velocity becomes v. Velocity becomes v. The distance travelled by a body in time t in time t can be found out by its by its average velocity. Average velocity. Average velocity. From the previous lesson, we know that average velocity equal to initial velocity plus final velocity by 2. So A equal to average velocity equal to u plus v by 2. Also distance traveled equal to traveled equal to average velocity into time. Average velocity into time. That means S equal to u plus v by 2 into t. This is the equation number 1. From the first equation of motion, v equal to u plus at. Putting this value of v in equation 1, we get S equal to u plus at by 2 into t. That is 2u t plus a t square by 2 equal to ut plus half at square. So S equal to ut plus half at square. Proved. This is the second equation of motion. These equations of motions very important to you, because from this equation, with the help of this equation, we can calculate initial velocity, final velocity, and uniform acceleration of a moving body. Now the third equation of motion. Third equation of motion. This is the last topic. Third equation of motion, that is V square equal to U square plus 2AS. The third equation of motion can be obtained from the third equation of motion can be obtained by eliminating time t from the first two equations of motion. From the first equation of motion, from the second equation of motion S equal to ut plus half a t square. Consider this is number equation 1. From the first equation of motion V equal to U plus AT. We can derive time t from this equation. Or AT equal to V minus U, AT equal to V, or T equal to V minus U by A. T equal to V minus U by A. Putting this value in equation 1. Putting this value in equation 1. Putting this value in equation 1. So we get S equal to U V minus U by A into T into plus half A V minus U by A whole square. from this equal to uv minus u square by a plus half a into v square plus u square minus 2 uv by a square equal to uv minus u square by a plus v square plus u square minus 2uv by 2a equal to 2uv minus 2u square plus v square plus u square minus 2uv by 2a equal to v square minus u square by 2a or s equal to v square minus u square by 2a from this 2as equal to v square minus u square from this v square equal to u square plus 2as. This is the proof of the third equation. This is the proof of the third equation of uniformly accelerated motion. This equation gives us the velocity acquired by a moving body by a traveling body. This equation gives us this equation gives us the velocity acquired by a body in traveling a distance s, in traveling a distance s. Okay, my dear students,